what if the next really big leap in artificial intelligence didn't emerge from, the usual places, not Silicon Valley this time?
Right, somewhere unexpected.
Exactly. What if it came from a surprising new contender, one that's, well, fundamentally challenging the global tech giants? Today, that's exactly what we're diving deep into.
That's fascinating.
We're going to unpack the honestly extraordinary rise of the Falcon series of large language models. These are developed by the UAE's Technology Innovation Institute, or TII.
TII, yes. Been hearing a lot about them.
And we want to explore how it's, well, rapidly reshaping the AI landscape as we know it. So our mission for this deep dive is really get into the what, why, and how behind Falcon's meteoric ascent.
Okay.
We'll look at its unique blend of open source thinking and commercial goals and, the profound impact it's having on who might actually control the future of AI.
Which is the huge question right now.
It really is. We've gathered a whole stack of compelling articles, research papers, industry reports. We've poured over them to really get to the heart of this story for you.
And that clarity you mentioned, host, speaker, about which Falcon we're even discussing, that's absolutely critical.
Right, because the name pops up everywhere.
It really does. It's quite prevalent, across different tech sectors, even in academic research. So just to prevent any confusion for our listeners right from the start, let me stress this deep dive. It's focusing exclusively on the generative large language models developed by the Technology Innovation Institute.
Okay, TII's LLMs. Got it.
Exactly. We nail that distinction down right now, so we're all on the same page.
Perfect. So let's unpack this from the beginning then. The Falcon project.
Yeah.
It wasn't just some sudden tech breakthrough, was it? It feels much more deliberate.
Oh, absolutely not sudden.
It really seems like the result of a very deliberate, exceptionally well-funded national strategy by the UAE. So what was the bigger picture? What was the grand ambition driving something this massive?
Well, the UAE's grand ambition here is, frankly, it's breathtakingly significant. They're aiming to establish themselves as a really formidable independent force in the global AI landscape.
Okay, a major player.
A major player, yes. And critically, it's about diversifying their economy, moving beyond that traditional reliance on oil and gas.
That makes sense. A long-term strategic goal.
Absolutely. And it's not new either. It's a very deliberate, long-term initiative you can trace back years. For instance, the UAE was the very first nation globally to appoint a dedicated minister for artificial intelligence.
Really? When was that?
Way back in 2017. Then in 2019, they launched the Mohammed bin Zayed University of Artificial Intelligence, MBZUAI.
Ah, yes, I've heard of MBZUAI.
Right, the world's first graduate-level AI research university. So they're laying serious academic groundwork.
Okay.
Then TII, the Technology Innovation Institute, that's the applied research arm of Abu Dhabi's Advanced Technology Research Council, ATRC, they set up their AI Research Center in 2021.
So the pieces are coming together.
Exactly. That was basically the direct precursor to the Falcon project. And we even saw an early sign of what they could do back in spring 2022.
Oh, yeah. What was that?
They released NOR. At the time, it was the world's largest Arabic language model.
Wow. Okay. So a clear progression.
A clear, escalating trajectory. All these carefully orchestrated pieces fit together, showing this national ambition, increasing capability, leading right to Falcon.
And the name itself, Falcon. It feels very intentional, doesn't it? I mean, beyond just the national bird connection.
It is. It's symbolic, absolutely.
What's the deeper message? This sort of geopolitical angle, maybe?
That's a really insightful question. Because, yeah, it's symbolic, but it's more than just national heritage. It does evoke strength, speed, agility qualities TII wants its models to embody.
Sure.
But you're right, there's a significant geopolitical dimension. Falcon is a key instrument of the UAE's, well, technological soft power.
Okay, soft power through tech.
Precisely. By developing and, crucially, open sourcing a world-class LLM, the UAE isn't just, trying to attract global talent or build a developer community.
They're making a statement.
They're directly challenging the long-standing U.S.-centric dominance in AI. This move could potentially create ripples, inspire other nations to invest in their own sovereign AI.
Fostering a more multipolar AI world.
Exactly, a more multipolar global AI ecosystem. It's a very strategic play to gain influence and independence in a technology that's critical for the future.
Okay, that makes a lot of sense. So before we dive even deeper into the models themselves, it really feels vital we double down on clarifying what we mean by Falcon.
Yes, absolutely necessary.
Because as you said, that name is just flying around everywhere. So many unrelated things share it.
You're absolutely right. Precision here is just key to avoiding misinformation. So let me reiterate. We're focusing exclusively on the generative large language models from the Technology Innovation Institute, TII's LLMs.
Got it. TII's LLMs.
To be crystal clear, we are not talking about other products, companies, or research projects that might also use the name Falcon.
Okay, like what?
So we're excluding various commercial software platforms, whether that's cybersecurity, like CrowdStrike Falcon, or local SEO tools,
Right.
or NSFW content detection, or even investment firms using the name. We're also not talking about hardware like Intel's upcoming GPU, Falcon Shores,
Okay.
or, consumer laser engraving machines, none of that.
What about academic projects?
Good question. We're also sidestepping unrelated academic research projects, things like vision language models for remote sensing, or AI for classifying diseases in actual falcon birds.
Okay, definitely not that.
Definitely not. Our deep dive is squarely focused on TII's LLMs, the ones spanning from, 1 billion up to 180 billion parameters.
And you mentioned correcting an error.
Yes, we saw one source attributing a 680 million parameter model to a company called Adarga.ai under the Falcon name. That's incorrect. Based on all major TII documentation, we're sticking to the confirmed TII models and their established sizes.
Wow, okay. That really helps narrow it down.
Yeah.
Essential to know exactly what we're discussing when we say Falcon.
Crucial.
Okay, so stage set. We have the UAE's ambition. We've defined our focus. Let's get into the models themselves, the Falcon lineage.
Let's do it.
So TII enters the ring March 2023, their first two big models. What did that initial release, Falcon 7B and 40B, look like? What kind of splash did they make?
Well, their debut in March 2023 was incredibly impactful. It immediately put TII on the global AI map.
Really that quick?
Instantly. They released two key models, Falcon 40B, which had 40 billion parameters trained on a huge 1 trillion tokens.
1 trillion tokens, wow.
And then the smaller, more agile Falcon 7B. Interestingly, despite being smaller, it was trained on an even larger dataset, 1.5 trillion tokens.
Okay, so data scale was key from the start.
Absolutely. Both models were built on a pretty standard causal decoder-only architecture. That's common, proven design for generative LLMs.
Right.
But what really grabbed everyone's attention was the performance. Falcon 40B basically shot straight to the top of the Hugging Face Open LLM leaderboard.
That's the big independent benchmark, right?
Yeah, exactly. Widely respected. And Falcon 40B outperformed established open source models at that time. Think Llama from Meta, Stable LM, MPT.
So immediate credibility.
Instant credibility. It showed TII was a serious top-tier player right out of the gate. And they didn't just release the base models, they also put out Instruct versions.
Ah, fine-tuned versions.
Yes, like Falcon 40B Instruct. Fine-tuned specifically for conversational AI, chatbot-style interactions, so they were ready for practical use almost immediately.
Very smart. Ready to deploy.
Made them immediately useful.
Okay, so that initial 40B success was impressive. But they clearly weren't stopping there, were they? What was the next move? It got even bigger, right?
That's right. TII definitely didn't rest on its laurels. They built on that success and unveiled Falcon 180B in September 2023.
Just a few months later.
Exactly. And this wasn't just, an incremental update. This was a monumental effort, a clear statement of their ambition and technical skill.
180 billion parameters. That's huge.
Staggering. 180 billion parameters trained on an enormous 3.5 trillion tokens.
3.5 trillion. The scale is hard to grasp.
It really is. And the training process itself was immense. It required something like 7 million GPU hours.
7 million.
On a cluster of up to 4,096 NVIDIA A100 GPUs. This really showcased TII's mastery of large-scale distributed training, managing that kind of infrastructure.
Incredible engineering feat.
Absolutely. And guess what? Performance-wise.
Back to the top of the leaderboard.
Secured the top rank again on the Hugging Face leaderboard for pre-trained LLMs. But what's even more impressive when you look at the benchmarks, its performance was shown to be right on par with Google's Palm-2 Large. That was the model powering Google Bard at the time.
Wow, okay. Palm-2 Large is massive.
Exactly. And it was demonstrably superior to Meta's Llama 270B.
Better than Llama 270B?
Yes. And this is despite Falcon 180B being roughly half the size of Pal M2 large in terms of parameters.
That's incredibly efficient then for its power.
Extremely. This really cemented TII's position right at the cutting edge of AI development.
Okay, so after hitting that absolute peak of scale with a 180B, it feels like TII's strategy shifted slightly. Is that right? Why have the pivot?
That's an excellent observation. Yeah, there was a definite evolution in strategy.
What was the new direction? What does Falcon 2 and 3 bring? It seems like efficiency became a bigger focus.
Precisely. After proving they could build these incredibly large, powerful models, TII made a very deliberate strategic shift. They moved beyond just raw parameter count and sheer power,
Towards
towards focusing more sharply on efficiency, accessibility, and introducing new modalities like vision.
reflecting market needs, more practical deployment.
Exactly. It shows a deep understanding that the market needs models that are not just powerful, but also practical and, importantly, cost-effective to deploy for a wider range of users.
Okay, so tell us about Falcon 2.
Right. Falcon 2 was the first big step in this new direction. The key model, Falcon 2 11B, so 11 billion parameters despite being smaller, was trained on a massive 5.5 trillion tokens.
Still huge training data.
Huge. And that rigorous training allowed it to show performance superior to, say, the larger Llama 3 8B model from Meta.
Interesting. Better performance with fewer parameters.
Exactly. And crucially, this generation introduced Falcon 2 11B VLM.
VLM, Vision Language Model.
Yes, their first vision-to-language model. This new multimodal capability meant it could process and understand both images and text.
That's a big expansion. Opens up lots of new applications.
A significant expansion beyond just text generation. Then came Falcon 3.
Right.
The Falcon 3 series really doubled down on this strategy. Powerful yet highly efficient models. It came out in 4 really accessible sizes, 1B, 3B, 7B, and 10B parameters.
So much smaller, designed for wider use.
Exactly. And the training for this family, an unprecedented 14 trillion tokens.
14 trillion, the numbers just keep getting bigger.
It's astonishing scale. The explicit goal here was to democratize access to high-performance AI. They wanted models that could run effectively on consumer-grade hardware.
Even a laptop.
Even a standard laptop, potentially. That focus on resource efficiency is absolutely crucial for enabling future edge AI applications, which we'll definitely get into later.
Right, running AI locally, not just in the cloud.
Precisely. And Falcon 3 also pushed the multimodal boundaries further. It introduced capabilities to process not just images and text, but also video and audio data for the first time.
Image, video, audio, and text. That's getting very comprehensive.
Significantly broadening its sensory input.
So it's clear they're not just scaling up and down, they're also innovating significantly, kind of under the hood architecturally.
Absolutely.
What about these cutting-edge developments like Falcon H1, Falcon E, and Falcon Mamba? What are they doing differently?
Exactly. TI isn't just making models bigger or smaller, they're fundamentally rethinking how these models are built to maximize efficiency and performance, often exploring really novel architectures in parallel.
Okay, let's start with Falcon H1. Hybrid, right?
Yes, Falcon H1. This is a fascinating family. Models ranging from a tiny 0.5 billion up to 34 billion parameters. It uses an innovative hybrid Transformer Mamba architecture.
Transformer Mamba, combining 2 approaches.
Correct. It blends the proven performance of traditional transformers with the linear scaling efficiency of state space models, or SSMs, like a Mamba.
Okay, what's the benefit of that?
The big benefit is it drastically reduces memory usage. This makes it ideal for processing very long contexts. We're talking up to an incredible 262,000 tokens.
262,000 tokens.
Yeah.
That's enormous context.
Massive. And because of this efficiency, these models can actually outperform pure transformer architectures twice their size in certain tasks.
Wow. Okay, what about Falcon E? The E is for?
Edge. Falcon E is a specialized variant explicitly designed for deployment in, well, infrastructure-limited environments.
Places without powerful GPUs.
Exactly. It's highly optimized to run efficiently on CPUs, aiming to move AI capabilities from the cloud directly onto real-world edge devices.
Makes sense. And Falcon Mamba?
Falcon Mamba 7B. This is TII's first open-source state space language model, or SSLM.
So not a transformer there.
A significant departure from the traditional transformer architecture that's dominated the field. Falcon Mamba 7B is noted for its low memory costs, high efficiency, and it's been shown to outperform transformer models of a similar size.
So TII is really pushing architectural boundaries.
Absolutely, cementing their role as a leader in architectural innovation.
It's a lot of innovation, especially around efficiency. If you had to sort of distill this whole evolutionary path from the huge 180B down to these hyper-efficient, specialized architectures, what's the underlying strategy? Is it just about making models smaller?
That's a great question, and I think it reveals a really sophisticated two-pronged strategy.
Okay.
The initial big releases, Falcon 40B and 180B, they served a crucial purpose: grab global attention, establish TII's technical credibility, prove they could compete with the giants on scale and raw power.
Okay, put down a marker.
Exactly. Prove, unequivocally, that a non-US entity could compete at the absolute highest level. But, having done that, TII pivoted.
Because massive models aren't practical for everyone.
Precisely. They recognize that while huge models are impressive, they have prohibitive deployment costs for most users. So the later focus on smaller, hyper-efficient models like Falcon 3 and these novel architectures like Falcon H1.
It's not just about size reduction.
No, it's a deeply pragmatic, business-oriented engineering philosophy. It directly addresses the practical needs of the market. This second phase more authentically delivers on that promise of democratizing AI.
How so?
Because a model that can run efficiently on a laptop or an edge device that's far more accessible, far more cost-effective than one needing a whole data center.
Right. Much broader reach.
Exactly. So this positions TII not just as a rival in the large model arena, but also as a pioneer in the race for efficient, physical, and edge AI.
Which many see as the next big frontier.
The next truly disruptive frontier, potentially. It's about making AI ubiquitous, not just powerful in the cloud.
That's a really clear strategic view. So that's a rapid and impressive evolution. Could you give us a quick flyby, maybe highlighting some key specs from our sources, just to underline the differences across these Falcon generations?
Certainly, yeah. Looking at the family overall, you see a clear progression. The first generation, the 7B, 40B, 180B models, all built on that causal decoder-only architecture.
Okay.
They incorporated key innovations like multi-query attention, MQA, for the 40B, and its extension, multi-group attention, MGA, for the 180B. Also, rotary positional embeddings, ROPE, and flash attention.
Right, the efficiency boosters.
Exactly. Their typical context window was 2048 tokens, and they were multilingual strong, mainly in English, German, Spanish, French.
Okay, Gen 1. What about Falcon 2?
Falcon 2, the key model there, the 11B, kept the causal decoder-only design, but importantly introduced multimodality with vision-to-language capabilities.
Processing images and text.
Right, a big step. Then the Falcon 3 family sizes 1B to 10B parameters takes multimodality even further, now processing image, video, and audio data.
Broader input.
Much broader. These are also specifically edge optimized, and they have a significantly expanded context window. 32,000 tokens.
Wow, a 16x increase from Gen 1.
Huge jump. Then you have the architectural innovators. Falcon Mamba 7B, that's the state space model. Significant departure, known for high efficiency, low memory cost, also 32K context.
Okay.
And finally, Falcon H1, ranging from 0.5B to 34B parameters. That's the innovative hybrid transformer Mamba architecture, extreme efficiency, and that astonishing 262,000 token context window.
Incredible.
So yeah, each generation and specialized model clearly builds on the last, targeting different aspects. Performance, efficiency, real-world application shows TII's agility.
Definitely. Okay, so we've talked about the impressive output, the evolution, but what's really happening inside these models? What gives them their power and makes them so efficient? Let's dig into the core architecture.
Okay, let's get under the hood. At their very heart, the foundational Falcon models, especially the 40B and 180B, are built on a causal decoder-only transformer architecture.
Standard stuff for generative LLMs,
Yeah.
right? Predicting the next word.
Pretty standard, yes. The core task is predicting the next token based only on the tokens that came before. Auto-regressive. That's how they generate coherent text.
But TII added some twists.
They did. Their implementation has several key refinements. One significant modification, which we first saw in GPT-J and Falcon adopted, is using parallel attention and multi-layer perceptron MLP blocks.
Parallel blocks, how does that help?
Well, in a traditional transformer layer, the attention output feeds into the MLP sequentially. By placing them in parallel, TII basically cuts the number of all reduced communication steps per layer in half during distributed training.
All reduced steps. That's how the GPUs talk to each other.
Essentially, yeah. How different parts of the model sync up across many GPUs. Cutting those steps dramatically reduces communication bottlenecks.
So faster training.
Speeds up training significantly. They also made other design choices for stability and efficiency, like removing all bias terms from the model's linear layers. And using the Gaussian error linear unit, or GLU activation function, it gives a good balance of performance and computational cost.
Got it. So foundational but refined. Now, the sources really highlight some fascinating innovations, specifically for efficiency, especially during inference. That's huge for practical use, right? The cost of running the model.
Absolutely critical. Inference cost is often the dominant factor long term.
So tell us about things like multi-query attention, MQA, flash attention, and rotary positional embeddings, ROPE. Held, how do they give Falcon an edge?
Okay, these are indeed critical innovations for efficiency at scale. Let's take multi-query attention, or MQA. This was in models like Falcon 40B.
How does it work?
In standard multi-head attention, each head usually has its own query, key, and value projections. MQA closely changes this. All attention heads share a single key and value projection.
Okay, what's the benefit of sharing?
The dramatic benefit is a significant reduction in the size of the K, Vcache. That's the memory needed to store the key and value states for the sequence generated so far.
Less memory needed during generation.
Exactly. During that step-by-step decoding, a smaller memory footprint means less data needs to be read from the GPU's slower high-bandwidth memory, or HBM.
Which means?
Significantly faster inference speeds, better scalability, and all with only a minimal hit to model quality. It's a huge win for efficiency.
Okay, that's MQA. What about MGA for the 180B model?
Right, for the even larger Falcon 180B, TII extended MQA into multi-group attention, or MGA. Instead of just one shared KV pair for all heads, you have multiple KV groups.
More groups.
Yeah, and the number of groups is specifically tied to the degree of tensor parallelism being used in the distributed setup. It keeps the memory-saving benefits of MQA, but is better optimized for these huge distributed training and inference scenarios. Reduces communication overhead between GPUs working on different parts of the model.
Very clever optimization for massive scale. Now, flash attention sounds revolutionary.
It really is. Flash attention is an algorithm that basically re-engineers the attention mechanism to be I/O-aware, meaning aware of memory speed differences. Standard attention often needs to write out the full large attention matrix to the GPU's main slower HBM memory. Flash attention avoids this. It uses techniques like tiling and recomputation to keep the intermediate calculations within the much faster on-chip SRAM. Think of SRAM as the GPU's super-fast scratchpad.
So it keeps things in the fast memory.
Exactly. This significantly cuts down memory read-write operations, which are often the bottleneck, the result. Faster training and inference, and crucially, it enables much longer context lengths than would otherwise be practical.
Makes sense. And finally, ROPE. Rotary positional embeddings. How does that fit in?
ROPE is how Falcon injects information about the position of tokens in a sequence. Unlike older methods that might just add a position vector, ROPE modifies the query and key vectors by essentially rotating them based on their position.
Rotating them.
Yeah. It's proven highly effective at encoding relative positional information, how far apart tokens are from each other, and it's become pretty much a standard for many top LLMs now.
Fascinating stuff. Okay, now, this hybrid transformer Mamba architecture in Falcon H1, it sounds like a potentially massive leap. Is it really a game changer, like some sources suggest? What's the core problem it solves?
I'd argue it absolutely is a significant leap, yeah. And here's why. It directly tackles one of the most fundamental limitations of the traditional transformer architecture.
Which is?
Its quadratic computational complexity. The compute cost scales quadratically O(n)2 with the sequence length n.
Meaning longer text gets exponentially more expensive to process.
Exactly. Transformers are great for comprehension, but this quadratic scaling makes processing very long sequences incredibly computationally expensive and memory hungry, double the text length, quadruple the cost, roughly.
Ouch. How do SSMs like Mamba differ?
State space models, or SSMs like Mamba, process sequences in a way that scales linearly O(n), much more efficient for long context tasks.
So Falcon H1 tries to combine them.
It aims for the best of both worlds. It leverages the transformer parts for their strong general comprehension, but harnesses the Mamba parts for their linear time efficiency and lower memory use, especially when dealing with those really long sequences.
And the result?
More stable, predictable, remarkably memory-efficient models. They can consistently outperform pure transformer models twice their size on certain benchmarks and handle those extreme context windows up to 262,000 tokens.
That really does sound like a game changer for handling huge documents or long conversations.
It's a massive leap forward for those
Mhm.
kinds of tasks. But this approach, it isn't just technical elegance, it reveals something deeper about TII's philosophy.
Oh, yeah. What's that?
It shows a deeply pragmatic, business-oriented engineering mindset. Think about it. Training a model is huge, but it's often a one-time or infrequent cost.
Right.
But inference running the model every time someone uses it, that's the continuous operational cost. That's what determines the total cost of ownership, the TCO, for any deployed AI app.
So these efficiency innovations directly target TCO.
Exactly. Innovations like MQA and this hybrid Mamba architecture are explicitly designed to attack inference cost by cutting memory bandwidth needs and computational load. This gives a powerful competitive advantage by significantly lowering TCO.
So they're building models not just for benchmarks, but for practical, cost-effective deployment.
Precisely. They're engineered from the ground up for cost-effective real-world use at scale. Makes them more commercially viable for way more applications.
Very strategic.
Mhm.
Okay, beyond the architecture, the sources really hammer home the importance of data. It's the fuel for intelligence, right?
Mhm.
What's TII's secret sauce with training data?
You've absolutely hit on a critical point. The cornerstone of Falcon's training, and honestly a huge part of its success, is the RefinedWeb dataset.
RefinedWeb. Tell me about that.
It's a massive, high-quality dataset TII created by processing publicly available Common Crawl web data, but their core philosophy here was quite innovative at the time.
How so?
They believed that a sufficiently large but crucially rigorously cleaned web dataset could actually yield better model performance than smaller, more manually curated datasets, which some others favored.
Interesting. So quality and quantity from web data.
Exactly. And their internal experiments supported this. They found adding curated data sometimes even hurt performance against a strong, clean web data baseline if not done super carefully.
So how did they build RefinedWeb? That sounds like a monumental task.
It was. They engineered a proprietary extensive data processing pipeline they call macro data refinement. This multi-stage process is a key piece of their IP.
What does it involve?
It starts with filtering, aggressively removing low-quality stuff, machine-generated text, adult content, other noise that could mess up the model or introduce bias.
Okay, cleaning out the junk.
Right. Then comes deduplication. This is huge. They perform extensive deduplication at multiple levels, fuzzy deduplication for near-identical documents, and exact string-level deduplication for repeated phrases and sentences you see all over the web.
Why is deduplication so important?
It's absolutely crucial to stop the model from just memorizing and spitting back common web content. It forces it to generalize better, to actually understand patterns rather than just parrot.
Makes sense. What kind of scale are we talking about for this data effort?
Immense scale. The initial collection for Falcon 40B gathered nearly 5 trillion tokens.
5 trillion.
And then the models were trained on vast amounts of this refined data. Falcon 40B used 1 trillion tokens. The big 180B used 3.5 trillion, and the latest Falcon 3 family trained on an even larger, unprecedented 14 trillion tokens.
But 14 trillion. Just incredible. Is it all web data?
Primarily English web data, maybe around 80% for the early models, but TII also mixed in other sources to boost capabilities, books, code, research papers, conversational text from places like Reddit, Stack Overflow.
A diverse diet. Okay, training models on that scale.
That must be an engineering nightmare. How did TII manage the orchestration, especially in the cloud?
It is absolutely an engineering feat. Requires world-class infrastructure and a super sophisticated approach to distributed computing.
Where do they do it? They leveraged AWS Cloud, running on Amazon SageMaker using those large clusters of NVIDIA A100 GPUs, up to 4,096 of them for Falcon 180B running simultaneously.
Wow. How do you coordinate 4,000 GPUs?
That's where their proprietary framework comes in, Gigatron.
Gigatron. Cool name.
Right. Built on PyTorch, Gigatron was custom designed by TII specifically for the challenges of training on cloud infrastructure, which can have different network setups than, say, an on-premise supercomputer.
What does Gigatron do?
It implements a sophisticated 3D parallelism strategy to efficiently spread the model and data across all those GPUs.
3D parallelism. What are the dimensions?
It combines Data parallelism, TP, splitting the data. Each GPU gets a model copy. Tensor parallelism, TP, splitting individual model layers across GPUs for huge models. And pipeline parallelism, PP, grouping layers into stages, pipelining data through GPU sets.
Okay, a complex dance to keep everything busy and communicating.
Exactly. And this 3D strategy was combined with the zero redundancy optimizer sharding technique, which further cuts memory use by splitting optimizer states across GPUs.
Lots of optimization. And TII was quite open about this methodology.
Remarkably so, especially compared to some closed-source competitors. They extensively documented their training methods and architectural choices in detailed technical papers, really aimed to foster open science.
So putting it all together, if I'm understanding this right, Falcon's success isn't just the model architecture. It sounds like the data quality that RefinedWeb pipeline and this sophisticated Gigatron framework are TI's real secret sauce.
You have absolutely nailed it. Falcon's success is as much a triumph of data engineering and infrastructure engineering as it is of model design.
It's the whole package.
Right. Many places can replicate a standard transformer, but creating a multi-trillion token, high-quality, heavily deduplicated dataset from the messy web, that's monumental, costly, and TII's true advantage.
And the training framework, too.
Same goes for orchestrating stable, efficient training across thousands of cloud GPUs. Gigatron is specialized, non-trivial to build and optimize. This creates a really powerful strategic dynamic.
How so? The strategy of open sourcing the weights but keeping the process secret.
Exactly. By open sourcing the final model weights, they give away the end product, the what, but they retain the proprietary, incredibly hard to replicate process, the how.
Interesting.
This lets the global community build an ecosystem around Falcon, driving adoption and innovation. But TII keeps the core capability to produce the next generation of state-of-the-art base models.
So stay ahead of the curve.
It solidifies their leadership through a strategy of controlled openness. They foster the community, but hold on to the keys to future development. Very smart.
Definitely sounds strategic.
Mm-hmm.
Okay, so with all that incredible work, architecture, data, training, how do these Falcon models actually perform against the big names on those independent benchmarks? Does topping a leaderboard really mean something?
It really does. They've proven themselves to be consistent top performers, and that third-party validation is absolutely paramount for credibility in this incredibly competitive field.
So they hit number one.
Both Falcon 40B and the flagship Falcon 180B achieved the coveted #1 ranking on the Hugging Face Open LLM leaderboard for pre-trained models when they were released.
And that leaderboard is respected.
Widely respected, yeah. It's a community effort, evaluates models on a comprehensive set of benchmarks, reasoning, common sense, factual accuracy, provides a standardized, objective comparison for everyone.
So hitting number one signifies real capability.
It signifies tangible, measurable capabilities that often surpassed much larger or more established models at the time. And this trend of top-tier performance continued. The Falcon 2 and 3 families also proved leaders in their size classes, often outperforming comparable models from Meta, Google, Alibaba.
Consistently strong. Any caveats about the leaderboards?
Just a minor one. Sometimes the process for including models, especially ones like Falcon that need that trust remote code, true flag to run, involves a manual review. So there might be a slight delay occasionally in the official ranking appearing. But the consistent high performance itself is the key validation.
Got it. Okay, let's get some direct comparisons then. How does Falcon actually measure up head-to-head with the Titans? Google's PaLM, Meta's Llama, maybe even OpenAI's GPT models? Where does it sit?
Right, the head-to-head is where it gets really interesting. And Falcon holds its own remarkably well, often exceeding expectations.
Let's start with the big one, Falcon 180B.
Okay, Falcon 180B. Performance-wise, it's consistently benchmarked as being right on par with Google's PaLM 2 Large.
The model that powered Bard, that's impressive.
Very, and it's demonstrably superior to Meta's Llama 270B across many key metrics.
Better than Llama 270B. Okay.
Now, compared to OpenAI's models, Falcon 180B generally scores somewhere between GPT 3.5 and the more powerful GPT 4 on most academic benchmarks.
So extremely capable for an open access model.
One of the most capable open access models available globally. Absolutely, that's a huge achievement.
What about the earlier Falcon 40B?
Falcon 40D was also a standout. Remember, this 40 billion parameter model notably surpassed the much larger Llama 65B model on the OpenLLM leaderboard when it came out.
Showing that efficiency early on.
Exactly. And even with the newer, smaller Falcon 3 models, TII maintained this high bar. The Falcon 3 10B model, state-of-the-art performance in the sub-13B parameter category.
Living its class.
And the Falcon 37B is highly competitive with other top models in its class, like Qwen 2.57B or Mistral 7B. So really, across different scales, Falcon has shown impressive strength against the industry's biggest names.
But performance isn't just raw power, right? Efficiency matters hugely for real-world use, for cost. How does Falcon do in terms of, performance per parameter, getting more bang for the computational buck?
That's a crucial distinction, yes. And Falcon's focus on high performance with greater computational efficiency is a key part of its value proposition, its competitive edge.
How efficient was the training, for example?
TII reported that training Falcon 40B needed only about 75% of the compute used for GPT-3,
Okay.
and just 40% of the compute used for DeepMind's Chinchilla model. That shows a dedication to optimization right from the start. They weren't just throwing infinite compute at it.
And this efficiency focus continued.
Even more pronounced in the newer models, the Falcon H1 family, with that hybrid architecture, explicitly designed to outperform models twice its size, purely because of its superior performance to efficiency ratio. It's about doing more with less.
Which means lower running costs for users.
Directly translates to lower operational costs. However, there's an important trade-off we need to acknowledge.
Okay, between power and accessibility.
Exactly. While Falcon 180B is exceptionally powerful, its inference costs are substantial. Running it needs hundreds of gigabytes of VRAM, even with quantization to shrink it.
So out of reach for most people.
Effectively, yeah. Places it out of reach for many organizations, individual researchers. Prohibitive hardware needs, that's a barrier.
Whereas the smaller models.
Smaller models like Falcon 7B offer a much more practical balance of performance and cost, makes them far more accessible for wide deployment. And that's where TII really doubled down with Falcon 2 and 3.
Makes sense. Any efficiency comparisons with competitors like Mistral?
Yeah, it's interesting. While Falcon 7B is efficient, some highly optimized competitors, like Mistral 7B, can sometimes beat it in raw tokens per second throughput. It just illustrates there are always complex design trade-offs, Different models optimize for different things, memory, speed, quality. TII is clearly exploring all these angles.
Fascinating. Okay, let's look at some actual numbers to drive this home. Can you give us a snapshot of scores on key benchmarks, maybe MMLU, ARC, HelloSwag, Truthful QA, Winogrand?
Absolutely. Let's pull up some comparative numbers. Keep in mind these are snapshots and benchmarks evolve, but they give a good relative picture.
Okay.
For Falcon 180B, MMLU around 70.4, ARC 69.8, HelloSwag 89.3, Truthful QA 59.8, Winogrand 87.9. Pretty strong across the board.
How does that compare to, say, Llama 270B?
Llama 270B, MMLU 68.9, ARC 65.6, HelloSwag 87.1, Truthful QA 52.8, Winogrand 85.0. So you can see Falcon 180B generally edges it out on several key metrics, despite potentially fewer parameters than some competitors it was compared against.
Okay. What about Palm 2 Large or GPT 3.5?
Palm 2 Large, much bigger, shows higher scores like 78.3 on MMLU, 87.5 on Winogrande, though not all data points are easily comparable. GPT 3.5 Turbo, a strong proprietary model, hits 70.0 on MMLU, 85.5 HelloSwag, 60.0 Truthful QA, 81.6 Winogrande. So Falcon 180B is right in that ballpark, sometimes better.
Very competitive. Now the smaller, newer Falcons. Falcon 310B.
Right, Falcon 310B Instruct. This one scores 73.1 on MMLU, very high for its size. 64.9 ARC, 84.8 HelloSwag, 65.1 Truthful QA, 82.2 Winogrande. It's performing incredibly well, often beating larger models from previous generations.
How does that stack up against Llama 3.8B or Mistral 7B?
Good comparison. Llama 3.8B Instruct gets 66.6 MMLU, 79.5 ARC, 82.1 HelloSwag, 77.4 Truthful QA, 81.3 Winogrande. Mistral 7B Instruct has 62.6 MMLU, 78.9 ARC, 81.4 HelloSwag, 72.8 Truthful QA, 77.8 Winogrande.
So Falcon, the 310B looks really demonstrate Falcon's competitive edge, larger models rivaling or beating established giants, smaller models leading their categories. Shows the strength of their approach. Definitely paints a picture of high performance. Okay, let's shift gears slightly. Falcon is largely open source, which is a huge part of its story, its appeal.
A massive part, yes.
But it's not simple, is it? Especially around the licensing. There's even been debate about open washing. What's the real deal there? What's TII's motivation?
This is a really nuanced but critical part of Falcon's strategy, and yeah, it sparked a lot of discussion. At its core, Falcon's community approach is built on permissive licensing.
Mostly Apache 2.0 based.
Exactly. Most models use the TII Falcon license based on the highly permissive Apache 2.0. That's a big differentiator from, say, Llama 2's more restrictive custom license.
What does Apache 2.0 allow?
Royalty-free commercial use, broad freedom for developers and businesses to build on, modify, deploy Falcon in products without paying TIR royalties for basic use. That part is genuinely open, encourages adoption massively.
Okay, but there are nuances, especially for the big 180B model.
Right. The licensing isn't totally uniform. Falcon 180B's license includes a specific acceptable use policy, or AUP. Standard stuff prohibiting harm, generating false info to harm people, defamation, harassment.
Okay, that sounds reasonable. What's the controversial part?
The more significant part, where the open washing debate comes in, is a provision in the 180B license. It requires any entity wanting to provide hosted access to the model as a commercial service.
Meaning running it like an API for paying customers,
Yeah.
competing with cloud providers.
Precisely. If you want to do that, you need to get additional consent from TII first.
So not totally free for that specific commercial use case.
Correct. And from a strict open source initiative OSI definition perspective, some argue such commercial hosting restrictions deviate from true open source freedoms. That's the basis of the open washing critique.
What's TI's likely motivation for that restriction?
It seems pretty clear it's a strategic control point. They likely want to prevent, say, a huge cloud provider from just taking their flagship model, which cost an absolute fortune to develop, and capturing all the commercial value by offering it as a service without any collaboration or giving back to TII.
Protecting their investment and controlling the high-end commercial ecosystem.
Exactly. It's a way to maintain some control, ensure the massive investment yields some return or strategic partnerships, rather than just becoming a free commodity for their biggest potential competitors. It's a very pragmatic balance between fostering adoption and protecting their core strategic assets.
Makes strategic sense, even if it ruffles some open source purist feathers. Okay, so this open source strategy doesn't mean there isn't a strong commercial engine behind Falcon, right? It sounds like a sophisticated dual approach. How is TII building a business?
That's precisely right. TII and its parent, ATRC, have set up a very sophisticated dual strategy. They want widespread adoption and commercial success. To turn the research into economic value, ATRC established two key entities.
Okay, who are they?
First, Venture One. Think of this as the commercialization and investment arm of ATRC.
What's its role?
Its crucial role is identifying and funding innovative use cases and proposals that leverage Falcon models. They provide promising projects with compute resources, financial backing, basically incubating new businesses and apps around the Falcon ecosystem.
So stimulating innovation using Falcon.
Acts as a powerful accelerator. Then second, there's AI-71.
AI-71, that's the dedicated AI company.
Exactly. Launched by ATRC and Venture One, specifically tasked with commercializing Falcon models, AI-71 is the main vehicle taking Falcon to enterprise markets, initially focusing on key sectors like medicine, education, law.
What does AI-71 offer enterprise?
Enterprise-grade solutions, comprehensive support, APIs built directly on Falcon. But a key differentiator for AI-71 is its commitment to data control and privacy for clients.
How do they address that? That's a huge enterprise concern.
They enable decentralized data ownership and offer self-hosting options. This directly addresses that major concern enterprises have about sending sensitive data to third-party clouds or APIs.
So businesses can keep control of their data while using Falcon.
Right. That resonates strongly with businesses prioritizing data security and sovereignty. Gives AI-71 a distinct competitive advantage in the enterprise space.
Okay, that covers the big enterprise play. But how are they nurturing the broader developer community, making sure Falcon gets wide adoption from individual coders, startups, researchers?
It's really a multifaceted approach designed to make Falcon as accessible and attractive as possible across the board. They know a thriving ecosystem is critical long-term.
So what are the elements?
Firstly, APIs and accessibility. They offer a range of APIs, a general AI-71 platform API for various models, plus specific model endpoints for tailored use, makes integration much easier.
Okay.
Secondly, heavy focus on community engagement. TII launched things like a call for proposals, inviting innovators to submit ideas for a novel Falcon application.
And they support the best ideas.
Exactly. Promising submissions get direct investment, crucially in the form of training compute power. That's a powerful incentive for innovation.
What else? Hackathons.
Absolutely. They actively host hackathons. Events like the Falcon Hackathon run by LabLab.ai encourage rapid prototyping.
What kind of projects come out of those?
All sorts. Low-code RA agile builders, medical diagnostic chatbots, compliance tools, financial assistance. Really shows the versatility of the models and the community's creativity.
And integration with platforms developers already use.
Crucial element, Hugging Face integration. Falcon models are deeply integrated into the Hugging Face ecosystem. That's the de facto hub for open source AI now. Makes them super discoverable, easy to download, experiment with, fine-tune.
Okay, so putting all these pieces together, the permissive license, Venture 1 and AI 71, the developer outreach, what's the overarching strategy here? Is it just tech leadership or a bigger commercial game?
Oh, it's definitely a bigger commercial game. A sophisticated platform play, you could call it.
A platform play.
Yeah. Think about it. A purely closed source model struggles for developer mindshare against open alternatives. But a purely non-commercial open project wouldn't meet the UAE's economic goals.
So TII's hybrid strategy bridges that gap.
Exactly. They use the permissive Apache 2.0 based license to drive massive adoption, build a huge user base that's the top of their commercial funnel.
Okay.
Then, those specific hosting restrictions on the biggest model, that acts as a strategic control point. It effectively channels large enterprise customers needing managed services, support, scalable solutions.
So grabs AI 71, the commercial arm.
Precisely. So the open source release functions as powerful marketing and distribution for their premium enterprise offerings. It's a classic strategy. Build community with an open core, then monetize via enterprise-grade services. Ensures impact and revenue.
Very clever. Okay, let's get concrete then. We've talked tech, strategy, but where is Falcon actually being used in the real world? Where is it making a tangible difference for businesses today?
Right, the applications. Falcon's capabilities are proving particularly useful in data-intensive enterprise settings, where intelligent automation and insight generation can really drive efficiency and strategic advantage.
Like which industry?
In business process outsourcing, BPO, for example. Falcon's being used to streamline complex workflows, automating document processing, enhancing quality control by intelligently checking info, ultimately cutting operational costs while keeping service quality high.
Makes sense for BPO. What about insurance?
The insurance industry is using it for multiple things. Claims processing automation, definitely, but also more advanced risk analysis, spotting subtle fraud patterns, analyzing customer data to recommend tailored policies.
Improving efficiency and personalization.
Both. In finance and risk management, institutions are using Falcon to analyze real-time transaction data for proactive fraud detection, super critical.
Yeah, fraud's a huge issue.
Its predictive analytics are also used to optimize debt collection strategies, personalize communications while staying compliant, forecast market trends, even identify potential new customers, driving growth.
Healthcare too?
Even in healthcare. It can power intelligent patient chatbots for 247 answers, freeing up clinical staff. And there's that significant partnership TII has with the Bill and Melinda Gates Foundation.
Oh yeah, the LLM project.
Right, developing AgriLLM. It's Falcon-powered, designed to help farmers in developing nations make smarter agricultural decisions, especially facing climate change. Shows its potential for global impact.
That's fantastic. And the legal field.
In the legal field, Falcon enhances information retrieval systems massively. Law firms integrate it into internal search, helping lawyers find relevant case laws, precedents, documents much faster, speeds up case prep and research significantly.
So really broad enterprise adoption already. What about for developers and smaller businesses? How are they using Falcon as more of a toolkit?
Yeah, for developers and smaller outfits, Falcon is a really versatile toolkit. Enables AI-powered apps that might have been out of reach or too costly before.
Like what? Content creation.
Definitely content generation. Automating creation of website copy, blogs, social media posts, media companies using it for quick news summaries, even creative stuff like poems, scripts. A real boost for smaller teams.
Translation too.
Machine translation, yes. It offers precise, context-aware translation across languages like English, German, Spanish, French. Super helpful for global businesses, documentation, customer comms, collaboration.
And building custom tools. Chatbots.
Those specialized Instruct versions are perfect for building custom AI agents and chatbots. Developers create agents for specific tasks, automate internal workflows, build interactive dashboards that pull insights from company data, and intelligent layer over operations.
Search as well, making search smarter.
Improving information retrieval and search, yeah.
Yeah.
Moving beyond simple keywords, Falcon can decipher user intent, context, deliver more relevant results, enhances internal knowledge bases, customer-facing search bars, better user experiences all around.
Okay, so lots of current applications. But what does this all mean for the future? Is TII aiming beyond just text on screen, beyond chatbots, something more ambitious?
Absolutely. While many current uses are text-centric, fitting cloud LLMs well, TII's strategic direction, especially with the newer models, points towards a much broader, incredibly ambitious future: physical AI.
Physical AI, like robots and autonomous systems.
Exactly. TII researchers have explicitly mentioned ambitions in robotics, autonomous vehicles, smart cities. These applications have incredibly strict requirements.
Like what? Low latency,
Yeah.
offline capability.
Exactly. Low latency, real-time decisions often need offline functionality. A robot can't wait for a cloud round trip to react to something right in front of it.
So how does Falcon enable this?
The development and release of Falcon E, the Edge models optimized for CPUs, and those highly efficient Falcon 3 models that can run on laptops. Those are the technological foundations for this vision.
The building blocks for embedded autonomous AI.
Precisely. These are the building blocks needed for that embedded autonomous future.
So this isn't just iterating on current AI. It's rethinking where and how AI operates. The long-term goal seems to be embedding Falcon as the core intelligence in systems interacting directly with the physical world.
That seems to be the powerful, potentially transformative vision, yes. Current enterprise use is the immediate market, but the long game looks towards embedded autonomous systems.
Fascinating. Okay, let's try to summarize then. What are Falcon's undeniable core strengths? What makes it so competitive?
Well, Falcon has several really compelling advantages. First, its openness and permissive licensing. That Apache 2.0 base fosters a massive global ecosystem, drives adoption, sets it apart.
Okay, openness. What else?
Second, performance and efficiency. Top leaderboard rankings prove state-of-the-art performance, but critically, it's engineered for superior inference efficiency, MQA, hybrid architectures, offers a great performance-to-cost ratio.
Performance and efficiency. Got it.
Third, superior data quality. That huge investment in creating the high-quality, large-scale RefinedWeb dataset. Meticulous data focus is a primary driver of capability, a hard-to-replicate competitive moat.
The data secret sauce.
Exactly. And finally, it's evolving multilingual and multimodal capabilities. Starting multilingual, now pushing strategically into vision, audio, video, broadens applications, future-proofs the platform.
Okay, strong foundation. But no project is perfect. What are some of the challenges or weaknesses Falcon faces?
You're right, a balanced view is crucial. One significant weakness is the high resource requirement for the flagship 180B model.
Too big for most people to run.
Exactly.
Yeah.
Immense memory demands hundreds of GBs of high-end GPU VRAM, makes it prohibitive for all but the most well-funded places. A major barrier to adoption for their biggest model.
Okay, what else?
Ecosystem maturity and learning curve. While growing incredibly fast, the Falcon ecosystem is still younger than some competitors, like Llama. New users might face a steeper learning curve finding tools, tutorials compared to more established platforms.
Makes sense. Anything else?
The potential for overfitting. That's a challenge for all LLMs, really. Fine-tuning powerful base models like Falcon needs careful data curation, validation expertise to stop it just memorizing the training data and losing generalization. Requires skill.
And language support.
And language support nuances, yeah. While multilingual, proficiency is highest in the languages most represented in training English, some European languages. The recent dedicated Falcon Arabic model is a necessary step to address this, expand capabilities beyond its current strongholds, acknowledges where more work is needed.
Okay, fair points. So, looking at the whole picture, strengths, weaknesses, strategy, what does Falcon's emergence truly mean for the broader AI market? For big tech, how disruptive is it?
Oh, its emergence has had a profound, undeniably disruptive impact, challenged several basic assumptions.
How so?
Firstly, it challenges the status quo. It definitively proves state-of-the-art AI can be developed outside Silicon Valley and be shared openly. Directly challenges the dominance of closed-source models from OpenAI, Google, Anthropic. Shay's innovation isn't exclusive to one place or business model, fosters new global competition.
Okay, challenges the incumbents. What else?
It significantly contributes to democratization. By lowering the barrier to entry for powerful AI tools, Falcon empowers a global community researchers, startups, enterprises to innovate without vendor lock-in, fosters competition, accelerates development across the field, opens AI to more diverse perspectives globally.
And for the UAE itself.
It significantly increases the UAE's influence. The project successfully established the UAE as a credible, influential force in global AI, potentially inspires other nations to pursue sovereign AI initiatives, contributes to a more diverse, resilient global tech ecosystem, more multipolar, less concentrated power.
Really shifting the landscape. Okay, given all this ambition and impact, what's next for Falcon? What's on TII's roadmap? What frontiers are they aiming for?
TII has laid out a pretty clear and ambitious roadmap, shows continued commitment to pushing boundaries. They're focusing on three key technological frontiers.
Number one.
First is multimodality, clear strategic priority. Already did vision language with Falcon 2 VLM. Falcon 3 family sees continued expansion into video and audio processing too. Enables apps that understand the world in a richer, more human-like way, towards more complete sensory AI.
Okay, full spectrum multimodality. Number two.
Next, exploring mixture of experts, MOE architectures for future model.
Mixture of experts. How does that work?
MOE is a promising technique for building even larger, more capable models more efficiently. Instead of one giant network, it uses numerous smaller, specialized expert subnetworks. The model learns to route tasks only to the most relevant experts.
So more efficient use of compute for bigger models.
Can lead to dramatic increases in performance and capacity without a proportional jump in inference costs. Smarter use of resources.
And the third frontier.
And finally, that continued strong focus on edge AI. The pivot towards smaller, efficient models, Falcon 3, Falcon E, Falcon H1 signals a long-term vision, embedding AI directly into devices. Cars, robots, consumer electronics, real-time intelligence without cloud reliance, essential for critical autonomous systems.
So ambitious tech goals, how are they supporting this institutionally, commercially?
They're building out the structures too. In February 2024, they launched the Falcon Foundation.
A nonprofit.
Yes, a nonprofit backed by an initial $300 million commitment. Its mission is advancing open-source generative AI, fostering collaboration between developers, academia, industry, acting as a hub, providing open compute resources.
Supporting the ecosystem.
And AI 71 and strategic partnerships will keep driving enterprise adoption and funding future R&D. A prime example, their collaboration with NVIDIA.
Making Falcon H1 available via NVIDIA.
Right, via NVIDIA's NIM microservices. That move simplifies enterprise deployment, helps scale sovereign AI capabilities for governments, corporations worldwide, makes integrating these powerful, efficient models into existing infrastructure much easier.
Sounds like a comprehensive plan for the future.
Yeah.
So bringing it all together, what does this all mean for you, the listener, and for the future of AI? Falcon feels like more than just models. It's a statement, isn't it?
It absolutely is a statement. Falcon is a transformative force, fundamentally altering the dynamics of innovation, access, leadership in AI. It proved state-backed research outside traditional tech hubs can produce world-class open-source AI.
Lowering the barrier to entry globally.
Dramatically lowering it. Its focus on data quality, architectural efficiency for practical use, permissive licensing it, truly democratizes access to advanced AI capabilities, shifts the power dynamic.
And its ambitious roadmap, full multimodality, next-gen architectures like MOE, the huge frontier of edge computing it, really positions Falcon as a defining player in AI's next chapter. For us, it certainly redraws the map of global AI power, makes it much more complex, much more interesting.
Which raises a really important question for you, the listener, to consider. How might that balance between open source freedom and commercial control continue to evolve, especially as more nations chase sovereign AI? And how will TI's unique hybrid strategy influence that global shift in the years ahead?
That is a deep thought to leave us with. Thank you for diving so deep with us today into the world of Falcon AI.
My pleasure. It's a fascinating story.
Absolutely. Until next time, keep exploring.